Hi everyone. In the last class we have discussed the classification of rectifiers. In this class we will study each and every one. Okay, so first, as we have classified them, so let us go ahead with the first converter, that is single phase half wave diode rectifier with R load. So for every converter we have to deal like this only. So whatever the things we are doing here, so this is the basis for the all converters. So let us go ahead with the first. I will draw the diagram of wave single phase of wave diode rectifier. So it is the diode I have to draw here. So this is the diode, this is the load, resistive load, and this is the single phase supply. That's it. Okay, I will give the names also. Yes, this is the single phase supply, single phase supply. This is diode, let me call D. This is resistor R, so the output voltage is V0, and here the input voltage is Vs. So these are the things. Okay, so if you go ahead with the waveform, so please concentrate here. I am drawing the waveform here. So this is the waveform. So sine wave, so let me draw voltage and currents. Okay, that's fine for me. So first we have to see input voltage. So what is the input voltage, how it is going on. So the input voltage is like this. So whenever you want to draw input waveforms, it's better to keep some lines like this. Okay, so this is V1, I mean this is the first positive of cycle, next negative of cycle, positive of cycle, negative of cycle. So you can draw the dotted lines also here. It's better to draw dotted lines here. Okay, maybe with some very light color. So I am drawing here, just see from this point onwards I am drawing dotted lines. And here also I am drawing the dotted lines. And here also I am drawing. So generally we have to take at least 2 cycles so that it will be fruitful. So please draw this one so that you can have the idea. Yes, so it should be like this. So let me write the things here. So this is Vs and this is V naught, and even I am drawing I naught also here. Okay, so this is simple diode rectifier. So what exactly happened in diode rectifier is there are two cycles here, positive off cycle and negative off cycle. What is the characteristics of the diode? So this is P and this is N. So if it is in positive off cycle, I like to draw one more diagram. If it is in positive off cycle, you can check what will happen. So this is the resistor. If it is in positive off cycle, it will be plus and it will be minus, and it is P and it is N. As P is connected to plus and N is connected to minus, this diode is in forward bias. As this diode is in forward bias, so what will happen? As the diode is in forward bias, so there is it is in forward bias, so there is a current flowing through these 2 points. Hence it is short circuited. Okay, then as the current is flowing through this is I naught current, and there is a voltage here V naught. You can check like this. Okay, so this is the concept of first positive off cycle, as they are in. So this is I naught and this is V naught. Okay, now as we are drawing V naught and I naught, generally even though we have drawn Vs here, so there is a common practice to draw other things also. So the common practice is we can have dotted lines of sinusoidal wave here. So it is the source voltage exactly equal to source voltage, so that you can easily draw your output voltage. Okay, with this I can draw. Now I am drawing the output voltage with the red color. You can check up. So as we know right from beginning onwards, so actually the voltage drop here is very less, that is 0.7 volt only. So let me neglect that voltage drop, and I feel that whenever it is in positive off cycle, the whole voltage of Vs will be appearing at V naught. So it is simply following source voltage only, like this. After that, what will happen? So in negative off cycle, what will happen? In negative off cycle, let me go ahead with this. In negative off cycle, it is minus and it is plus. So what will happen to the diode? We will check. So this is the resistor R. So in negative off cycle, this is P and this is N. So P is connected to negative and N is connected to positive. So clearly it is in reverse bias. So these two, there is no current or very less current flowing through that. So that is a negligible current. As there is no current here, the output voltage, which is equal to I naught into R, will be equal to 0. So hence the waveform will be like this. It is 0. In the negative off cycle, it is completely 0. Okay, and in the next positive off cycle, same thing will be repeating. V naught is following the Vs, and in negative off cycle it is 0. So this is called single phase off wave rectifier. If you see clearly, only off wave is only rectified and remaining wave is the 0. So that's why this is called off wave rectifier. Okay, so this is called off wave rectifier. So this is the explanation for this, and we can check the voltage across thyristor also. So Vt. So how to find Vt? So Vt, if you see in positive off cycle, the voltage across Vt is 0, and negative off cycle it is completely. Okay, let us have Vt should be here. It should be plus and minus. As there is no current flowing through this, V naught will be 0, and what is Vt now? So Vt is equal to minus of Vs. According to Kirchhoff's voltage law, Vt is equal to minus of Vs. So if I draw this one, if I want to draw Vt here, so how to draw? So in positive half cycle it is, let me write here, Vt is equal to 0 here and Vt is equal to minus Vs here. So Vt equal to 0, so it is 0 here and here it is minus negative, and then it is following like this. Okay, so according to Kirchhoff's law, you can write Kirchhoff's law here. According to Kirchhoff's voltage law, Vs is equal to Vt plus V0. Please remember this, every time it will be like this only. So now you can easily say Vt plus V0 should be equal to Vs. Okay, it is exactly equal to Vs, and this is also equal to Vs. So if you add these two, you will get this one. So this part is very simple part to understand. Okay, Vs is equal to V0 plus Vt, and if you go to other things also, so same principle will work out. So obviously you will get a good idea of how to develop waveform for the Vt. Okay, voltage across the diode or voltage across the thyristor in later cases. Okay, as it is diode, let me have T only, D only, diode. Okay, so without confusing you, I am writing Vd. This is Vd. Okay, so this is the waveform part. So now let us move to another part. So that is the how to do it for the average voltage and RMS voltage. So how to calculate output average voltage and output RMS voltage.